All right, let's talk about a problem that literally gives operations managers nightmares. The late shipment. It's a huge deal. It can cost a ton of money, you can lose customers, and it can really damage your company's reputation. We're going to walk through a scenario, step by step, to see how some core engineering principles can bring order to all that chaos.
So this is the question, isn't it? It haunts every production manager and engineer out there. It feels like you're constantly putting out fires, just running from one crisis to the next, but you can never find what's starting them in the first place. Let's put a face to this problem.
So let's follow the story of an engineer named Alex. She's been tasked with solving this exact problem. And for her, this isn't just some textbook exercise. Nope, her company's future is riding on this, and the pressure is on. Okay, so picture this. Alex walks onto the production floor, and it's just controlled chaos. Everyone's working overtime, stress levels are through the roof, and even though people are working harder than ever, orders are still late. The symptoms are crystal clear, but the actual cause? Total mystery. This brings up a really important point about how we even define quality. It's not just about making a perfect product. As this quote points out, if that perfect product shows up late, you've basically failed. So for Alex, this completely reframes the problem. Being on time isn't just a nice to have, it's a core part of the product. Alex knows that just blaming her team or asking them to work even more hours isn't the answer. That's just a band-aid. She needs to get to the root of the problem. It's time to stop treating the symptom, which is the late shipments, and actually diagnose the disease.
So she becomes a detective. She starts a methodical process of elimination. First up, the machines. Are they breaking down all the time? Nope. She checks the data, and uptime is over 98%. Okay, so it's not the machines. Next, the workforce. Are people slacking off? No. In fact, their productivity is actually above average. So finally, she starts tracking the raw materials as they come into the factory. And that's where she finds it.
And this is it. The aha moment. The entire assembly line is grinding to a halt because they're constantly waiting for critical parts that just aren't there when they need them. The people aren't slow, the machines are working fine. The real problem, the root cause, is a supply chain that's basically running on pure guesswork. Alex realizes the company has been flying blind, just reacting to problems. The only way to fix this for good is to get proactive. And the very first step is to stop treating customer orders like random, unpredictable events and start looking for the pattern hidden in all that noise. I mean, just look at the raw data Alex is dealing with here. It is all over the map. Sales go up one month, then down the next. Trying to plan your inventory based on this, it feels impossible. How in the world do you create a stable production plan from this kind of chaos? Well, she turns to a classic quantitative tool, time series analysis. Now, this isn't some crystal ball. It's a really powerful statistical method that helps you find the hidden patterns, the trends, the cycles that are buried deep inside messy historical data. It's the key to turning that chaos into a forecast you can actually rely on. And within that world of time series analysis, she starts with a really simple but incredibly powerful technique called the moving average. The idea is, instead of reacting to every little spike and dip in sales, you average the data over a few months. It just smooths everything out so you can see the real trend. And would you look at the result? The difference is night and day. The jagged bars on the left, that's the volatile raw sales data. But that much smoother line on the right, that's the 3-month moving average. It shows a much calmer, clearer picture. All that random noise gets filtered out, and what emerges is a predictable trend you can actually plan around. She found predictability in the chaos. Now, Alex has a solid forecast. Okay, so with that reliable forecast in hand, Alex can finally go after the root problem, the component shortages. It's time to build an inventory system that's based on data, not drama. For this, she uses another fundamental tool called the Economic Order Quantity Model, or EOQ. This is a classic engineering approach to inventory. Its entire job is to figure out the single most cost-effective amount of a component to order at any one time. The logic behind EOQ is really just a trade-off. Think about it. If you order massive batches of parts, your warehouse fills up, and your holding costs, like insurance, space, the money tied up, they just skyrocket. But if you place a bunch of tiny little orders all the time, your ordering costs, all that admin work for each purchase, go through the roof. EOQ is all about finding that perfect sweet spot right in the middle.
And this is the formula that finds that perfect balance. Now, don't worry about memorizing the math here. Just focus on the concept. It weighs three really important things: the cost to place a single order, the total demand that she got from her new forecast, and the cost to store just one unit in the warehouse for a year. She just plugs in her company's numbers, and it gives her the answer.
And there it is. The formula gives a clear, data-driven answer. The most cost-effective order size for their most critical component is exactly 1,000 units. No more guessing, no more panicked phone calls to suppliers, just one single optimized number to guide everything. And this is what the new system looks like in action. It's so predictable and smooth. As soon as the inventory level drops to a specific point, an order for exactly 1,000 units automatically goes out. The new parts arrive right when they're needed, which prevents shortages but doesn't create a bunch of wasteful overstock. The chaos has been replaced with a calm, efficient rhythm. So, Alex's solution worked beautifully. But you and I both know the real world is rarely this simple. So, let's take a minute and tackle a few of the most common questions that always pop up when you try to apply these models in real life.
Okay, this is a big one. The EOQ model we just talked about works great when your demand is pretty steady. But what do you do in situations with lumpy demand? Where you need a huge batch of components for one specific production run and then nothing for a while.
Yeah, for that exact scenario, you need a different tool. Standard models don't really apply. The right tool for the job here is called Materials Requirements Planning, or MRP. See, instead of forecasting demand for the part itself, an MRP system actually works backward from the final product's production schedule. It figures out exactly what you need and precisely when you need it to hit that schedule.
All right, what if you want to think bigger picture? What if you want to manage these fluctuations at a higher level, beyond just optimizing inventory for one part? What are the big strategies? Well, at a high level, you've really got three main playbooks. First, you can keep your production rate and your workforce totally stable and just use your inventory as a buffer to handle the ups and downs. Second, you can keep your workforce the same size, but use things like overtime or subcontractors to ramp production up or down. And third, you can just chase demand, produce exactly what's needed by hiring or laying off workers as things change. Each one has its own set of pros and cons. And finally, let's leave with this thought. We often think about these planning models as a purely top-down process, right? A planner makes a decision, and it just flows down to the factory floor. But is that really the best way? Or does true optimization happen when you combine that top-down strategy with bottom-up feedback from the very people who are actually building the product? It's something really important to think about for any real-world application. If you haven't already, get over to our YouTube channel, Mechanical Engineering Made Simple, where we post hands-on how-to videos, visual breakdowns, and practical engineering walkthroughs you can actually use. A family that solves together stays together.